think we can make a start. All right, so greetings everyone. I'm Tayo. I will be. I think I got some inspiration from Captain Johnson's last class to share this class as well. So what I intend to do is to go a little bit into magnetism, so that you can understand it and be able to, so that when you read the document yourself, you actually like magnetism. You have a love for it. It's not a difficult subject once you like it, okay? And then I hope this class will be able to encourage you to read more on it, and you might be able to picture something. So I will try to do some diagrams with us. I encourage that we come with the blue pen and the red pen as well. After we finish this class, I will go into some of the questions that was asked last week that we didn't have the time to touch. Somebody asked a question on if you take what course on your magnetic compass, is that the M or is that the C or is that the T, something like that. I will touch on a few things after. So let me share my screen. Let me go to a whiteboard. I hope we have our our sheet of paper, red pen and blue pen. Okay, I might be struggling myself because I have to use the technology that we have here. So the first thing is I want us to draw the hertz, basically, as round as, let's try something. Okay. So that's the hertz. Let me erase this. Okay, let me try again. Let me use black so that doesn't affect what I want to do. Okay, perfect. Okay, so if you have a sheet of paper yourself, please try and draw this. And of course, we know that we call this the knot. I don't want to use blue. Let me use another color that will not take too much shine away. Okay, now let me use red on this side. The knot, and this side will be, let me use blue, south. This is basic, right? Okay, so magnetism, the hertz is magnets, basically. We know it is not exactly on the pole, but for illustration purpose, just permit me to do this. So let's look at it in your own diagram. I want you to draw lines that is going from the north to the south. I need it to be, what color should I use for this? Let me use red, maybe use red as well. So from the north to the south, okay. That's the magnetic field from the north to the south, okay? Excuse my use of technology, it's not perfect, but I hope it will pass the message. So from north to south, I will, if on your own drawings, try to make it maybe better. And if possible, I will try to do that as well. Put some arrows to say it's going from the north to the south, okay? So let me put arrows if possible. Yeah. So that's the direction, the flow of the magnetic field from the north to the south. Okay. Put my phone on silent. All right. Okay, so now what happens is we know that the law of magnets, like poles repels or like poles attracts. Okay, so if you put a metal, so let me have the equator as well. It will be helpful. Equator. So yeah, okay. So now, if you are a ship is a metal, is metal, you know, the properties are of metal. So let me draw a ship as well. What can I use? What symbol should I use to draw a ship? Okay, let me try this. Maybe it will work. Oh, okay. Now I don't, let me put it somewhere close to the equator. Can I move it? Yeah, I should be able to move it. Okay, good. All right. So for emphasis sake, that is our ship, all right? Don't laugh. Okay, so that's our ship. Now, like poles repel or like poles attract. So if anybody's following me, so if this is red, let me put red here. No, don't do this, red. Red. Okay, and this side will be blue. All right. So if this is your ship, what do you think this side will be? Let me see. Who do we have? Unfortunately, who can I call on? Pina, are you there?
Yes, I am.
So what do you think this side will be?
Since you said unlike poles attract, I think that would be blue.
Correct. Yeah, perfect. So that will be blue. So this side will be blue. So let me use B, right? But for your own drawing, please, you can do all that. And this will be what? Peter, what do you think?
That would be red.
Okay, so, all right, so perfect. So that will be red. All right, so this section, what can I do? This part of your ship will be blue because the magnetic pole is traveling through it, but it is unlike poles that will attract. Because if this is red, it will repel. So that means it will not be able to stay here. All right, so and this is red. Now you have something in between the ship. Who can guess that thing is? What that thing is? Very, very important. That's why we are in this class today. Something that is here, that is always pointing north, magnetic north.
The magnetic compass.
Yeah, so your compass needle, right, is here. So we are concerned about the tip of your compass needle. Okay, so your compass needle is there. This is emphasis. Of course, the compass needle is very small compared to the ship, okay? But for emphasis sake, so let's say that's your compass needle. Now, your compass needle is always pointing towards magnetic north. It would want to, how do I call it? If there is no obstruction, anything at all, it will want to point north, okay? And so we are talking about you're trying to build a ship at the equator in this eddy right now. Now, once the ship is being built, there's a lot of things that go on. There's a lot of eating, there's a lot of armoring, there's a lot of, all that, which is chemistry basically, or I don't know. Yeah, I think that's the easiest way I can call it. Putting things together. So the ship during its build takes some form of permanent magnetism in some part of the ship. So like the bow and the stern. And I'm giving emphasis, assuming you are building a ship or the equator facing north, right? If we get this basic, then we can probably build our ship somewhere here and have an expectation. We can build it somewhere there. What do you expect it to be? And maybe if we build it not facing north-south, what is going to happen as well? So your magnetic pole, again, what color do you think this magnetic pole will be? Anybody?
I think it will be blue
Why?
because you said unlike poles attract. So for it to be looking for that, it's looking for the opposite of it.
Yeah, but your ship bow is blue.
If if my ship bow is blue and is looking for my ship's bow, then it will be the opposite of that, which will be red.
So it will be red. So okay, that's the logic. Okay, that's the logic behind it. It's more complicated, but if you understand the basic logic, then you can build that into it. So let me have a bit of text here and call this side red. So for emphasis, for the purpose of this, our magnetic needle, the tip of our magnetic needle is red. Now, there are permanent ions, there are permanent magnetism, induced magnetism, subpermanent magnetism that the ship experiences. So as I was saying, when the ship is being built, due to the hammering and the heat and everything, there are certain things that become permanent magnets. So you take the bow, the hull, for example, part of the hull, the major part of the hull will become like permanent magnets. Anywhere they go, they just remain like that. So for life of this ship, the bow will be blue, the stern will be red. Now, if the ship is sailing south, heading south, what is going to happen? If this ship now sailing southward, sailing towards the South Pole, what do you think is going to happen? I'm liking Pina's voice already, so I think I'll just stick with Pina for this class. So what's going to happen, Pina?
I think if the ship is facing southwards, because the bow would be facing south as well,
Yeah.
then the ship would be pointing towards the bow, but that's what I think. And it's still going to remain red. It doesn't change.
Yeah, so yeah, that's fine, but you know the south magnetic pole is blue. So you now have the ship, the bow of the ship, permanently blue, now facing south, which is blue. Then there's going to be some reactions. You understand?
Okay.
So, okay, I'm not going to reaction now, but I'm just trying to open your mind to see it. So, for the life of the ship, built on the equator, in the north-south heading this way, the bow will always be blue. The stern will always be red. So, as we will turn the ship, we will go on maybe 45 degrees to starboard or port, and we will think through together, what do you think would happen to the magnetism, to the magnet of the vessel? Okay, so there are some things called induced magnetism that we experience as well. So, for example, when you're using your engines, the funnel is hot, right? And when the funnel is hot, for you to pass magnetism through an object, you need the temperature. Okay, so when it's hot, it will pick up some form of magnetism. It depends on your heading. It depends on what is in the area. It depends on a lot of things. So sometimes your funnel could become blue, and sometimes it could become red. Okay, so it works that way. There are some form of magnetism that are like semi-permanent. Over time, over the years of the ship, it will slowly lose its magnetism, basically. But it's not like the funnel. The funnel is like a start and stop, especially if you are calling ports regularly. You stop it, you start it, different ports, different hemisphere or whatever. Every time you stop it and it cools, you start it again, it's hot, it takes magnetism and and all that. So those are the like three type of magnetism a ship will be you can experience on the ship. So the permanent, like the hard ions, you have the induced soft ions, and you have subpermanent magnets. Okay. Now, I hope people are you beginning to see what I'm trying to paint here right now. So because now if we alter this vessel, can I take this? Can I catch it? No. So if we, yeah. So let me see if I can turn this. Will I be able to turn it? I don't know. No, I cannot turn it. Shame. What can I do? I need to turn this. I want to turn this a little bit to starboard. Captain Uzai, do you know if I can turn this? You don't think so,
sure.
right?
I'm not sure I'm good in this, but
let's try something. No, that doesn't work. Let me try. I want to try and see what we could do. Okay, so anyway, guys, you just have to follow me with your imagination, right? I'm testing the power of your imagination. Sorry if I probably had a whiteboard, I might be able to do a better, to explain this better. But you guys are good with imagination. Most of you are in love anyway, and love is imagination. Okay, so let's now assume that this vessel, we've altered it to, is now on this heading. It's not on the north-south heading anymore. So we've come to about maybe 30 degrees to starboard. Does anybody, EA, are you there?
Yes, I'm here.
All right, so we have now altered this vessel to starboard a little bit. And so tell me, what do you think happens to the the needle? Explain, what do you think will be the reaction, magnetic reaction of the needle?
We turn it to starboard a little. The magnetic field on the North Pole tries to bring it to the North Pole, while the vessel also the needle tries to follow the heading of the vessel, while the North Pole tries to counter the needle tries to follow the heading to the starboard, while the North Pole also tries to pull it back to its position, I think.
Okay, so so you said, you remember that the needle, right, is red.
Yes, sir.
So the needle is red. So, and the knot is red. So what happens with that reaction?
It repels.
Exactly. So it repels. So is that what you said, or have I changed your answer?
I think you've changed the answer.
Okay, guys. I don't know. Can you picture what I've just tried to explain? Could you picture it, EA?
Yes, sir. Yes, sir.
All right. So the tip of the magnetic needle is red. So if you look at it, the common logic, like poles repel, unlike poles attract. So this will be pushing. Okay. Someone is not hearing me. I think people are hearing me. I think it might be from your side. Check your setting. Yeah, you raised your hand. Yeah, please go ahead if you raised your hand.
That was a mistake, sir.
Okay. Yeah. I don't know how. Maybe. I don't know how I can be of help. Captain Busa, if you can help me chat up Alpha Mike. I think he's having some audio problem. So help see how he can help him. Okay, so guys, I just need you to keep following me in this journey of love, in the sense that, so now we have moved our ship's edit a little bit. We have, let me see if I can. So this is red. Because now we have exposed, it's not in the north-south heading anymore. We have slightly exposed the needle. So there's not just the reaction. Of course, there's a blue reaction and there's this red lines I've drawn before. But right now we can see that it's now like exposed to the red itself coming from the Earth's magnetism. Let me put it this way. I'm exaggerating here, guys, but it's just for you to be able to get the picture. So this and the needle will repel itself, and the blue will try to attract it a little bit more. Now, if we, let me undo some of this, maybe it might help us to, okay. Let me select. Okay, that works. So draw something again. So let us now put this, we go to maybe 90 degrees. We are now sailing this way. What happens to the needle when we are in an east-west direction? Anybody wants to try with their imagination?
Yes, I'd
Please
like
go
to
ahead.
try.
Yep.
So now I think on an east-west direction, the needle is open to both the blue from the bow and the blue from the south. It repels the north because it's red, and this blue in the south attracts it.
Okay.
And the blue in the bow also attracts it. But I think the magnetic force of the south is obviously stronger than the magnetic force of the ship. So I think it would attract it more to the south. Okay,
so you are of the opinion, and I like this, that we might have a deflection. Instead of it to be this, we might have something pushing it this way, right? Is that what you mean?
Yes, yes.
Okay, because it's being repelled from the north, but it's attracted by the south, and the bow here is also, keeping it. So we might have something like this. Is that your explanation?
Yes, sir.
Yes, that's if you're heading in this direction now, right? If you're going east. What if you're going west?
If we are going west, it will still be the same thing. It will be deflected to like the west of it.
So
the west of that direction. So it's
something like this.
Yeah.
Because we have more magnetism on this side,
the south, and there's a repulsion from the north.
And there's a repulsion from the north. So those are the basic ways to start to understand it. So, again, I'm not a very good teacher. I don't think I am a very good teacher, but my work is to make you see it as simple as it is, so that when you actually carry your book to read it, you will be able to use your imagination of love and fantasies to fantasize about magnets, and magnetism and all that. Now, okay, so we have just put it on a ship. There are no other. This is just a plain ship, no other obstructions or distractions on this magnetic needle. Just the bow, the stern, and the north and south. So let's go back to, maybe we should keep some. Let's go back to our first love, which is this one. Come on. And let us add a little bit more to it. Okay. Where it gets interesting. Is it on this north-south heading? Okay, so you are on this same ship right now, in the shipyard, or you have a container terminal in this site. Container terminal somewhere here. So let me draw. Without even going to container terminal, let's first add some things on your ship. Okay, so you have you put your funnel, and you are a dredger. Okay, so let's say you're a dredger and you have to put your funnel somewhere. You cannot put it at the stern for some reason. Your navigation lights. Good. You have to put your navigation, your masthead lights. And because you're a dredger, you couldn't put it at the middle. So you got some exemption from your flag state in compliance with rules. Rule, collision regulation. Okay, let me off my mic, or maybe I should ask which rule. No, maybe not today. So you put your masthead light here. Is it big enough? No. Okay, so that's your masthead light. Your masthead light, sorry, your mast, the navigation light, the mast for your navigation light is that. It is not at the center of your ship. It is behind your compass needle, and it is to your port side aft. What do you think the effect will be on your compass needle? Let me see, who's there? FN. Is FN there? Oh, I like somebody that is on the bubbles bow. This is Umar. Are you there or you're hiding?
Actually, I'm hiding, sir.
All right, no problem. Don't hide. Talk to me about this. So, what do you think the effect of that will be on your compass needle?
The effect of what, sir?
So here you have put your mast for your navigation lights.
Okay.
And because you're a dredger, you can't put it at the middle exactly. So you have put it a little bit to your port side aft of the needle. What do you think the effect will be on your compass and your compass needle?
Sir, yeah, I think it will be dragging by the side.
So it depends on what it is going to become. Is it going to be blue? Is it going to be red? Okay. So that is how these things start coming into play. If you understand, that's where you're beginning to think about what's a deviation now. We are now, we're looking at that. I'll paint another picture. So you have your phonens, and you have put your funnel, the ship's funnel here. Yeah, it's not perfect drawing. So that's your ship funnel. What effect will it have? Some ships have the accommodation is also probably halved, right? So some vessels have the accommodation forward of the compass needle, or they have a superstructure forward of the compass needle. Some will have a superstructure aft of the compass needle. Some will have a crane somewhere here, your provision crane. What could it be? Some will have two cranes. Some will have, if you keep seeing everything you are building you're adding to the ship, you're affecting the magnetism. Some of them will be soft ions, like I said, like the phonens, that will be changing from time to time. So sometimes your phonens is red and sometimes is blue. How will it affect your compass needle? Are you guys following me? Are you getting the picture? I'm trying to paint. Fina, are you getting the picture?
Yes, I am.
Okay, so those are let's call it disturbance, but these are necessary disturbance for the commercial life of the vessel. It's not there for it to be convenient for you as a navigator. It's for you to work with what you have, but you can begin to see what all this means. And now when you're talking about the hard ions, the correctors, the Flinders bars, the bucket, the Ealing bucket. Now, when you heal at sea, what happens to your magnetic needle? All those stuff. So that is where you have those corrections that are there. So some of them are forward and aft. Some of them will be outward shapes, components, more or less. So if you begin to see it from this little picture that I think I have drawn, you might be able to get a clearer picture of it. Yeah, Mubarak, please go ahead. Raise your hand.
Yes, evening once again. I'm a little bit confused regarding the funnel, for example, the one you have from the aft side. And we know the bow of the vessel is already blue, as we are taking example of this vessel. So how are we going to know, since if it is going to the red side, definitely it will attract. If it is going to the blue side, it will repel. So for example, the funnel from the aft side, how is it going to affect? I mean, how
Is anybody here, Mubarak?
Yeah, I'm hearing him slowly. I'm hearing him. I'm trying to hear him. Yeah, finish your question, or if it's possible, you can increase the volume or maybe speak closer to the mic.
Yeah, can you hear me now, please?
Okay, I'm hearing you, and I will repeat your question. Please go ahead. I will repeat the question for everybody.
Yeah, my concern is if we have, say, a funnel or a crane from the aft side, which definitely that ion, it has its own blue side, which is also its red side. And for example, this vessel that we're having, the bow is blue, which means the magnetic pin is also blue, as I've said. So how are we going to know that the funnel down there is from the red side or from the blue side?
Okay, good question. So I'll ask everybody, for those that did not hear Mubarak. So it's talking about the funnel, for example. How do we know if the funnel is blue or red? Is that your question, right? In summary.
Yes, that's the question.
Okay, so like I said, one, your funnel is something that probably changes over time. Why? Because your funnel gets heated up every time you're using your engine. So for you to pass magnetism or to alter magnetism of any metal, you need to introduce heat. So once your funnel is hot, depending on where you are in the hemisphere, depending on the direction of travel, depending on a lot of things, your funnel could be blue and your funnel could be red. So in this case, for example, we are south, right? Our funnel is in this position. Is our funnel going to be blue or is it going to be red? Now, when we're talking about an object like a funnel, I understand that some funnels are very big, some are very small, but we're going to take it as one. So we're not going to say some part of the funnel is red, some part of the funnel is blue, all right? So let's just take it as one object, okay? So now we are sailing this direction, our funnel is already hot, we're having this magnetism. Is it going to be blue? Is it going to be red? In this case, for example, if we are going in the east-west direction, is it going to be blue? Is it going to be red? If you're sailing south, is it going to be blue? Is it going to be red? What do you think, Mubarak?
Yeah, based on this diagram, if I understand, so it's gonna be the same as the hemisphere it is. For example, if it's gonna be from the south and from this part, so it might be red. I don't know if I'm correct.
Okay, so if, for example, I'll put you up, I'll challenge your answer, for example, and I'll say the ship is the old ship itself. That's good. I like that. The old ship itself is now in this hemisphere, in the north hemisphere. So what's going to happen to the funnel? Is it blue or red?
So if it is there, probably it's gonna.
Okay. All right. So now, if it is this way, it's not because it's in the hemisphere. That's why it is. The bow is blue and the stern is red. No, don't get it mixed up. It's just the fact that the travel, it comes in from the north to the south. Okay. Yes. And we know that like poles will repel, unlike poles will attract. So in the process of building the ship in this heading, you're still going to have the bow here will still be blue and the stern, because if you look at the metal, if you have a magnet with you, even though no matter how short the magnet is, either a short magnet or a long magnet, the ends are different. Okay, so it's not because some part of it is in the south hemisphere or some part of it is north hemisphere. So there will be north pole, there'll be the red and the blue in every magnet, whichever the hemisphere is. Okay, so now when a compass adjuster is trying to adjust your compass. Those are the things they will be putting into consideration. Or if you're going for class 1, those are the things you have to be thinking about. There's one, the last oral prep we did, I asked guys about what would be their concern if they are taking compass error, if they want to calculate a compass error or imports, for example, if they're checking anything on their compass imports. I was hoping they will go into a bit of magnetism, because when you import, you're likely going to have cranes, you're going to have containers, you're going to have other shapes, and those things will affect your magnetism. So do you want to be doing all these things in ports, basically? If you're going to be doing it in port, it's going to be done by a compass adjuster that knows the port areas. You're probably going to have a swing outside of port limits. Is it going to be like the same day, considering everything, the soft ions on your shape, the magnetism, how it plays. So those are your line of thought. You're not trained to become a compass adjuster. I think it's a long-term training. And I don't know if we have any, for example, in Nigeria. I think they have few in South Africa, maybe 1 or 2 in South Africa, basically. But so it's a skilled training. But the idea for this is to help you engage brain, so that when you pick up, you don't even think compass is boring. So people just think compass is boring. I think it's an interesting subject if you can break it down into pieces. And you can see why they'll be telling you that you should correct with the spheres. And when you want to correct with the spheres, you can write this down, please. You need to use 1 brain and 2 hands to correct when you're working with the spheres, for example. Are you bringing it in or you're taking it out? What are you expecting to see? And what are you trying to correct? So if you have a clear picture of what the magnetism around you look like, then you can understand what you're trying to correct for. There is a crane. You have just added a new crane. So for those working in the offshore industry, for example, they have just added something new to your vessel, a frame. What is not just stability. You have to think about your compass as well, because it's going to have an effect on it. They've just added a new landing area or whatever of significance to your vessel. You just had a collision, for example, on the side of your vessel. Something's going to happen. There's been an impact. That probably it's transferred some form of magnetism. Is going to affect your compass. It's going to affect all those things. So that's why you need to be, to think through this very well. Okay, so I have just slightly built, added few things. Now we were talking about what else could it be? The second officer that just bought a very nice wristwatch, and is playing with the wristwatch next to the compass. You will see if you're on board and you take if your wristwatch is original anyway, don't do it with fake wristwatch, so that if it spoils, then you now say your wristwatch has spoiled. Take it close to the compass, and you will see the effect of your straps, the wristwatch itself, on the compass. If you get my point. So those things, they are real life. There's nothing you can do about it. You just have to understand it so that you'll be able to play with it, basically, or you know how to correct the error. So, for example, if you look at Captain Busayo's screen right now, you see that there's a fighting sword next to his head. Those are that's a metal. He's showing us that's a metal. If you take that close to your compass, it's going to have effect. So everything around you has zone effect. So now that's where you get. As we move around the ship, there's the variation. That's the natural phenomenon that happens with the magnets. There are errors. That's one. Now, every other thing you have added will cause a deviation. So the natural one is the variation. You pick that up from your chart. It will tell you the year the variation was calculated, and so you can calculate. You can bring it up to date to the present year with corrections you require. Then you need to know your deviation. All right. So when you carry out your compass, you swing your compass, Has anybody done a deviation card? Have you swing your compass to carry the deviation card on this, guys? Let me know. Who has done this before? Pena, have you done this?
I've been on board where they were swinging to get but I didn't understand what they were doing.
You understand what they were doing? Okay, that's good. Good admission. It's fine that it's fine to say that. So because I was on board once as well, and I said the guys should swing the compass, and they gave me gyro compass. They were swinging with the gyro, so they will say they'll swing to 0, and they want to know what so they'll swing the gyro. Yeah, that's right. They'll swing the gyro to 0, 0, 0, and they want to know what the compass is at 0, 0, 0. And I think it's the other way around. Okay, so what they're trying to do is, so let me go to the CDM because I think I need to answer that question on the C. Can dead man vote twice? This one I want to do will probably answer a bit of the question on the swinging of the compass, and also the question. I don't know who asked the question last week about yes, what you have is a magnetic compass. So if you take a reading from a magnetic compass, do you write it on C or you write it on M? What do you think, Tina?
I think you write it on C.
You write it on C. Okay. Who thinks it's going to be on M?
It should be on M, sir.
You think it should be on M? Okay.
Yes.
Why? Is it because it is called magnetic compass?
Yes.
Okay. So when you get you pick a reading from your magnetic compass, that's your compass course, right? And so is it your compass course or your magnetic course? Umar, what do you think?
I think it's magnetic.
You think it's magnetic, right? So, okay, I think it's your compass course. When you pick it from your magnetic compass, it's your compass course. You want to add your deviation to it to get your magnetic course. Then from your magnetic course, you add your variation to your magnetic course. So you add your variation to magnetic course before you get your true course. Now, this true course as well, this is what you have on your chart. Does not mean this is what you will stay on your gyro, because the gyro has something called the gyro error as well. So you need to apply your gyro error. Let me put gyro error. So you need to apply, what's this? Gyro error to get your gyro course, what you stay on your gyro actually. So guys, this is compass course. Maybe I should write it in full so that I won't write it in full. If you have your pen or a paper there, please note that what you pick from your magnetic compass, right, is your compass course. You need to apply your deviation to that to get a magnetic course. So because you picked it from a magnetic compass does not make it your magnetic course. Umar, I hope I've been able to change that thinking.
Yes.
It's very important. Yeah. So when you get your magnetic, you now have the variation to get your true. And this true, I know a lot of people just put this true as their gyro, but your gyro also has a gyro error, which I hope you calculate every time, every watch, at least once a day, once a watch. Yeah, you don't just write overcast, weather overcast, and it's not overcast, but the temperature is 38 degrees. Okay. God knows your number. Yeah, please, Pina, what's the question?
Do you always add the deviation? or you subtract sometimes and you add sometimes.
Okay, so who knows the answer to this? So there is two ways, right? So there's the this is how I remember it anyway. Can dead man vote twice? And the other one, if you're going from true to C,
You said
like
true virgins make dull couple.
oh, okay, I did not mention it. You mentioned that. Anyway, okay. So, of course, it depends. It depends on where you're going. Compass to C to M. What do you do to D? M to T. What do you do to V? And if you're going the other way around,
Cadet. Compass to true add easterly.
okay. So, Pina, did you get the answer?
So if you're going from compass, if you're calculating from compass heading to true, you're going to add east and subtract west.
Yes.
Okay.
And if you're going from true to compass, you're going to subtract east and add west.
Yeah.
Yes.
So yes, exactly. So again, please guys, what you get in your magnetic compass is your compass course. Not your magnetic course, please. Is your compass course. You had your deviation to this, and you get your magnetic. From your magnetic, you had the variation, then you get to true. Now the true, again, the gyro error you've been calculating, that you know your gyro error on that, that's what you now apply to put on your gyro, basically. Okay, I know a lot of you don't do this, but I have to say it because that's the right thing to do. Now, the question I asked during the oral is, if you're about to sail, you are just completing your pre-departure checking, and you realize that the gyro compass, it was serviced while you're in port, was not switched on. What will you do? Does anybody want to answer that question now?
I think you first inform the master.
Okay.
And then he would most likely turn it on.
Yeah, of course, you turn it on. So when you turn on your gyro compass, what do you think would happen?
It takes a while to settle.
How long do you think?
On my ship, it was, I think, the fiber optic ones. I don't think it took that long. I think about 30 minutes to 1 hour. I'm not really sure, but around that time.
About 90 minutes.
But usually a normal gyro takes longer for it to find knot and settle.
Okay, so now what's going to happen if the captain now says, okay, we have to sail. The pilot has been booked or whatever, he has to sail. So what are you going to do? You don't have gyro.
You're going to use your magnetic compass because according to SOLAS, is one of the requirements I can use it to sail, I guess.
So how are you going to use your magnetic compass now to sail? What are you going to do?
I think that is why the deviation should be known and the variation as well. So it's something I guess you have to do fast. So the calculation has to be fast and all these factors have to be known.
So you can understand the gravity of that, the deviation table you have, your compass errors, the variation log that you keep on what particular heading, because you can imagine you're going through a channel, you have to be sailing with your compass, not your gyro. Your chart is giving you true, but you cannot just steer your chart direction with your magnetic compass. So all that calculation, you need to go from T to C for your waypoints, at least until you get back to you get to your gyro settles. Now, when you are at sea, how do you know if your gyros are settled? Because it's best to settle your gyro in port, where you are sure of the heading of the key side, and now you're at sea and you have 2-3 gyros and they all settle on 3 different headings. What are you going to do? So, it's the job is not there just to drink tea and coffee. It is always to engage brain, because the consequences of negligence is not nice. at all. It's I have heard, not my ship, I have to say disclaimer. The ship got to the channel and they realized they did the checklist, but it was fine. Everybody knows the channel very well, and they were sailing, and receiver visibility came. Receiver visibility came in the channel. They couldn't see the boys anymore. Now, so okay, where are we? We're supposed to be on. What are we supposed to stare? And they realized that the gyros were switched off in the channel. What are you going to do at that point? So EA, please go ahead with your question.
Okay, when you were explaining the CDMVT and your gyro cost to stay, you mentioned that your chart is in the true cost, but what you have to stay is the gyro cost, if I'm correct. I think that's what you mentioned.
So what I said is this: your gyro is different from my gyro. Your gyro has arrows, which I hope you know, east or west. Some people, I use high or low, 0.5 degrees high or east, or 0.5 degrees west, or or low, or whatever. Do you know your gyro arrow? Because if you put exactly what is on the chart to your gyro without applying the gyro arrow, you will be some fractions or a whole degree off.
Okay, yeah. So when plotting the waypoints and the routes, when we get after plot, let's say we plot 2 waypoints,
yeah,
and we have a cost to stay on that,
yeah,
of which we plot that on a chart, which makes it true cost.
Yeah.
So when transferring that to the gyro for us to know the cost to stay, we add the gyro error to that before transferring it to the gyro.
You apply the gyro error. I didn't say add to. I had to. It's classical. I think we have lawyers among us, so they don't say that. I said add. I applied the gyro error. If your gyro error is 0, then that's it. That's it. So yeah.
Okay, I think that's clear now. Thank you, sir.
For most gyros, it is negligible. People don't do it, but that's the real thing to do. So going back slightly to this magnetism, I think it's on. I'm not too sure now, but I think on a nautical almanac for those on board, you might check your almanac, or is it? I think it's nautical almanac. Is it? Oh, no, it's stable. No, I think it's nautical almanac or one of those publication, maybe chapter 8 of one of them has something on magnetism. And I encourage you to go open it up and read it and build a picture in your mind of how this works. So follow what I've drawn here, for example, and see your ship. Look at your ship. Look at what you have on your ship. Look at your funnel. Where is it? The center. You see that it's hot sometimes. Think about it, maybe, and observe. Just observe the vessel. If you stay long enough, if you're on a particular heading, what happens to your magnetism? If you're on the opposite heading, especially if you have stopped in port for some time and you're going another time again, check. Just have a feel of it. Your cranes, if something new comes on board, you just received some new wires that you are coiling on a part of your ship. That's for those that are working on the maybe offshore vessels and all that. Then you just receive your spare wire and you are coiling it. It might just be a little deflection, but take note of these things. And once you begin to do that, you're beginning to think like Captain. You start seeing that you have some white beards that started coming out. Then you go and read the book again, and you see that magnetism is very easy. There is a coefficient A. Those are errors that there's really nothing you can do about it. The man-made errors, at installation or whatever. There's the B, there's the C, there's the E. I think there's a coefficient D as well. I think there's a K. So what does all these coefficients stand for? What are you correcting? I hope this picture will also let you see the purpose of the Flinders bar, the healing error bucket, the soft ion correctors and the hard ion correctors, what ship, what are they correcting? Sometimes, turn it upside down, all those things. So if you can get the picture, I hope it will be easier for you to read through. Does anybody feel they have a bit more understanding of magnetism with this drawing or with my explanation today? Anybody?
Yes.
Or if I've actually confused you the more, let me know. So Pina, you said you feel you've had a little bit more understanding of magnetism, right?
Yes, I think I do.
Yeah, I think you do. All right, so try and draw this again, maybe tomorrow. Just try and sketch it out tomorrow again. Follow the patterns. It goes from north to east, direction of travel, anything that is on the line. Think about it, okay, and alter your ship a little bit. If you do this, if you alter this, what's going to happen? What's going to happen to the blue? What's going to happen to that? So if maybe a crane comes in here and it's blue, how it's going to affect the needle? If the needle is always red, where was your ship built? Is it built in the north to south heading? If you know, I think so. I think most ships will be built north south heading or south north heading, something like that. But again, your ship will determine that. Check your compass deviation card, the back of it, if you still have the original one, and if where the compass adjuster actually did. Look at what was there and what's happening, because I noticed for example, when I was on LNG vessels, after some time, the flame bar is reduced. This is that. Is it because of the sub-permanent magnets that are waning? So they're not as strong. We don't have to correct those ones anymore. We don't have to have that much effect, and all that. So it's an interesting topic. Let me put it that way. Any question? Any further questions on this today?
I have a question.
Please
Apart from when maybe a new superstructure has been built on board, or a major change, or it has been in a place for a long time, how often should the magnetic compass be swung to find out the deviation?
Okay, so we swing magnetic compass every year. I don't know if anybody on this call has been on my ship when we did anyone. We do it every year, basically, to do it, and we enjoy. But you need to know, okay, like for example, retentions. If you're just leaving port, you've been on it, not just even leaving port. So while we sailed through the Indian Ocean, we were on a particular heading. I think EA might remember, we were on a particular heading for almost a week or two. At that point, if you change your heading, what is going to happen? So we are not swinging. I'm not talking about swinging right now. I'm talking about what the errors you can expect, the natural phenomenon of magnets you can expect. So you just alter 90 degrees after 1 week or 2 weeks at a particular heading. What's going to happen to your magnets, to your compass? How long will you wait for it to settle down, to lose some of those magnetism that has been disturbing it? So
I think it's a retentive error.
Yes, retention, exactly, retentive error. That's correct. So that's why I said retention. So if you look at what's the purpose of the Ealing magnets, what is the permanent 4.5 permanent magnets that are in the trays? What ship magnets in the tray? What is it actually correcting in the ship? The Flinders bar, what is it correcting? The soft ion sets, what are they to correct? So, for example, like I mentioned, coefficient A, this has a constant, human error in calculation, yes, as long as there's human. When you talk about coefficient B, you're talking about the 4.5 component of the permanent magnetic field, for example. When you talk about coefficient C, you're talking about the outward shapes component of the permanent magnetic field. Also, it has some induced magnetism that it is correcting at the same time. Coefficient D, as well. Coefficient E, induced magnetism. Coefficient D is also about induced magnetism. Then Elin, basically. So again, guys, it is interesting. I think so, not sure. It's your nautical almanac. Check it out, or somewhere. There's a compass, there's a book that contains compass. Or is it your miner's handbook? I'm not sure now. But somebody should please do this and try and read it. Try to explain it as in a layman term, someone else as well. Okay? Yeah. Is that Mubarak having raised his hand? Please go ahead.
Yeah, that's correct, Captain. I want to confirm regarding the swinging of the vessel for the magnetic card. Is it according to the book that you do it once in a year, or is just management of the company with the captain?
Good question. Wait, if you go into, for example, dry dock, you stay during dry dock, you have a refit, you have something new, you just come out from collision, you have this, you'll probably be doing a swinging of your compass anyway. And minus, apart from that, I think it might be maybe a requirement, but I do it every year. I can't remember exactly the requirement now, apart from those, the ones that I mentioned, compulsory refits, dry dock, blah, 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 required by class, collision or all that you have to do, or you have noticed an issue with your compass, maybe during heavy rolling, you notice something has moved or whatever, that one you have to do. But for me, I just do it every year. I might find out if there's a requirement to do it every year, to be fair, but I do it every year. Captain Afo, do you think there's a requirement to do it every year? Is it as per SOLAS or is just a good practice?
I think it's just good practice doing it every year.
Good practice. Okay. So guys,
I'm reading here, and it says that it's supposed, according to ISO, that the maximum should be 2 years, but vessels transiting the Panama Canal are required by the canal authorities to have valid compass deviation cards issued within the previous 12 months.
Okay, so
that makes a year.
Now, if you're going into what does the rule say again about when you are in their local authorities, whatever they want you to do. So I guess for vessels that are passing through to do that. Yeah. So thanks for bringing that up. Where are you reading that from?
Google.
Dr. Google. So guys, like Captain Johnson said last week, once you come on watch, one of the things you need to check when you're taking over watch, check your magnetic compass, see that it's actually moving, that it's not dry, it's not, everything has not evaporated. Okay, check for bubbles, check for the free movement of the gimbals. Those things are easy to check if you are at sea anyway. Even if you are looking from the bridge through the telescope, you can see a lot of these things. Check that the spares are in the right place. It has not moved due to pounding or rolling, or something has loosed, some screw has loosed. And if you're on the bridge and you're hearing something moving from left to right on the Monkey Island, it might be good to go and have a look. It might be one of the spares that are falling off and is running from left to right. The needles, check how that is the needle moving, okay. Linder's bar, sometimes just check this thing. Don't just cover it and wrap it up and leave it for the rest of the watch. Open it and see what it looks like. Take a picture with it, take a selfie with it actually. Anybody that takes a selfie with their magnetic compass, send it to me. There's a price. There's a price for it. Not so with canvas, so remove the canvas and take it. I'll take a picture of it. Okay. Thank you very much. Thank you. All right. So that I think that is it for today. I don't know if anybody has anything to add, but I want us guys to at every time engage brain when you're on board. be professional at this operation. Don't just, is there, why is it there? Ask questions. If nobody is there to ask you questions, ask people outside that might be interested, and you to go and do some research and explain it to someone, you know. Be professional at your field, okay? It's for the best of all of us, okay? Thank you very much, guys. It's always a pleasure. I've had a nice time today. Okay, anything else, please? Or any question? Or maybe I'll pass on to Captain Afolabi if he has a plan for us.
Yes, I just want to chip this in. For the guys on board, please try and practice this, try and read about it, try and know in depth about it as well, because it's what you learn on board that sticks even than what you read in the books. So if you know you are still having an opportunity on board, still try and think about. Mubarak, your hands is raised. Is it raised before?
Yeah, it was rest before I have to lower it down. Sorry. Yeah, it's okay.
So that's it for me, guys. Thank you, Captain Tyler. Today was really lovely. So many notes here. And yeah, so next week we'll be here again next week as well, and it's going to be another interesting class. Captain Hansen, Captain Joshua, I will greet you. I will greet everyone in the class, JJ, everyone. All right, see you then.
See you guys. Sorry, while sharing the screen, I couldn't see a lot of names. I couldn't see everybody. Now that I've come out of the screen, I could see. All right, guys, have a nice one.
Okay.
Take a selfie with your magnetic compass. I'll send to me. There's a prize for the best picture. Best picture has a prize. Take care. Bye.
Yeah.
Thank you, Captain Tyler.
Bye. Bye.
Bye. Thank you.
Thank you, Captain Tayo, Captain Busaya, and everyone.
Thank you. Thank you. Thank you very much.
It's really a nice class. Thank you, guys.
Thank you.